Well, hello everybody. Good afternoon. It's a great pleasure to have you here at the Red Hat booth. And today, right now, we're going to talk about Minishift, the container development kit. Just in case you ever wondered, how do I start to play a bit with containers, with distributed execution and everything else? Well, here, we'll show you how you can have a full feature development environment for you to start developing containers and playing with scalability and distributed computing and anything else. Okay, my name is Edson Yanaga. I'm a director of developer experience at Red Hat. My Twitter handle is @Yanaga. And just in case you're wondering, I'm a Brazilian Japanese. Yeah, maybe the only one I've seen so far. Yes, not the typical Brazilian you would expect, but I am. I also happen to be a Java champion and a Microsoft MVP, and I work for Red Hat. How cool is that, you know? But that's a real weird world. We live in open source. We're all talking about that these days. And I have to tell you that in all of these discussions that we're having, cloud computing has become the de facto way for you to be running and developing and testing your applications. And you see, many different providers, when we have this race to commodity, when all of the different cloud computing providers are providing the exact same services, we need to find a way for us to prevent what we call lock-in, right? Because if everybody is doing the exact same set of things, if everybody is providing the exact same of services, they will race to the bottom, they will race to the zero, because the only way they can compete is in price. But since then, each one of the cloud computing environments will try to lock you in their platforms, right? So if you decide to use one specific service from one specific cloud computing provider, you will be locked. So the cost of moving from one cloud computing provider to the other will be very high. And the way that we have to avoid this kind of lock-in is open source. Open source is the best alternative that you have to prevent this lock-in in cloud computing environments, okay? So you should always be trying to, about open source solutions. Of course, there's the thing that you can contribute, you can use, but you can reuse all of the open source solutions in any cloud computing provider that you have. In fact, you can reuse these open source solutions either on-premise, either on private cloud, or hybrid cloud, or public clouds. And why should you choose open source besides avoiding lock-in? I like to say that no matter how big your company is, no matter how innovative your company is, no matter how many great engineers your company has, outside innovation is always bigger than inside. You always have much more innovation happening outside any given company than inside. And with open source, you can have all of these great people which are outside all of these great companies to contribute and to produce something simply great. Of course, open source is not just about the code. Open source, I think for me, open source, it's about community. And when you have like a community, when I say community, you have users, you have people that produce software, you have people that maintain the software, you have people that help other people use that open source. That's what I call community. And when we have like big companies, for example, Google and Red Hat producing something together with this whole set of community from different other companies and different other users, you can expect something which is really great. And today, I want to show you and want to tell you something about the Kubernetes project, which has quickly become the de facto standard for running and scaling and distributing your container applications into productions worldwide. Kubernetes is an open source project sponsored by Google and Red Hat, and you can see even here at JavaOne and Oracle event, you see everybody's talking about Kubernetes. That's why it's so widespread, and everybody has chosen Kubernetes to run and deploy and develop their applications on clouds, right? But if you ever try to use Kubernetes either on your host or even your laptop, if you've gone through the installations and configuration scripts of Kubernetes, you know that it's very hard for you to set up and maintain that cluster. It's hard for you to get the things running. But you know that as developers, we have the obligation to be developing and testing our applications in an environment which is as similar as possible as the production one. So We can't just use like Docker containers in our notebook and expect them to behave properly when we deploy them in production using a cluster solution like Kubernetes. We should be able to use the exactly same configurations of Kubernetes or anything else running on top of that in our own notebook before committing that code into our source code repository, right? But it used to be very hard. That's why a very smart group of people decided to solve this problem. We have some very great projects in the community, the internet. I want to mention some of them. So I'm going to open my browser here. And if you just type, for example, in your browser, Minikube, is an open source project that was provided for you to try Kubernetes inside your notebook in a self-contained VM with all of the goodies of the Kubernetes world. So we, as Red Hat, we are providing what we call Minishift. So what is Minishift? Is your self-contained development environment for you to test and develop and try the things inside OpenShift and inside Kubernetes out of box. So we designed that for you to have this easy experience of having a full feature Kubernetes and OpenShift cluster inside your notebook. It doesn't need to be hard. You don't need like an Amazon or Google account for you to have the Kubernetes and OpenShift cluster for you to be trying things. You can have everything inside your own machine, okay? You can have your registry, you can have your Kubernetes, you can have your Docker host, you can have everything just out of box here. So Minishift is the open source version if you want to try to develop and test your containers using a distribution like CentOS. But you also know that, again, a DevOps principle is that you should develop and test your applications into an environment which is as close as possible to the production one. So you can expect for your application to behave properly. If you're developing your application on something like Ubuntu, you're testing your application on CentOS and you're deploying that on top of Red Hat Enterprise Linux, right? Because that's the scenario of many different enterprise companies. So you should be using, if your containers are going to be running in production on top of Red Hat Enterprise Linux, you should be developing and testing also on top of Red Hat Enterprise Linux. That's why we provided a tool which we call Container Development Kit. If you just go to our website, which is developers.redhat.com, you type it in, you go to the website, you choose here between technologies, and you pick Red Hat Container Development Kit. It's a free solution for you to download and install Kubernetes and OpenShift cluster on your notebook. Yeah, it doesn't need to be a notebook, right? You can use a desktop computer too. So you install it, you can follow the instructions. You also have like quick tutorials, quick follow-ups, and that's what I want to show you today. I'm just checking because, sorry, we know that during this conference we're having some issues with connectivity. And when you boot your Minishift instance, it's just check some bits on some servers in the internet, and I'm trying to boot my machine. I was trying to boot my machine, and I was having these connectivity issues. I just hope that it was able to boot up, but it didn't. So we're gonna for the failover. Let me switch back. But if everything went well, it's just a matter for you to installing the configuration. And if you want to use CDK, the only thing that you need to do to boot up your VM with all of your Kubernetes and OpenShift cluster running up here, you just have to type Minishift start. It will create and provision your VM, which will provide you with a Docker host, which will provide you with a Docker registry, which will provide you with a Kubernetes cluster, which will provide you with an OpenShift cluster running on top of your VM. And since it's running a VM, maybe you don't want to be accessed like a remote host to do this all the things. Once it boot up, you could access the Minishift console, just type in Minishift console, and if it was up and running, it would open an URL in my browser, which I could probably access my OpenShift console, okay? I'm just starting it again and hope that the internet works now for me to get the bits running. But before that, I want to show something else to you. And we as developers, why should we be trying something like Kubernetes and OpenShift? What I have to tell you, I've been working with the Kubernetes bits for quite some time, and even me as like an experienced developer, I struggle with the Kubernetes command line, with the Kubernetes concepts. It's not that easy for me to keep up and running with all of these new things that are happening in Kubernetes all of these days. So usually for me it's much easier if I just choose like an open source solution like OpenShift on top of Kubernetes, because it provides me a lot of different commands and tools that helps my life as a developer, right? And what are the cool things that me as a developer would want to try in a cluster environment like Kubernetes? I'll have to tell you that one of the great things that we achieved in the past few years is what we call zero downtime. We want to deploy our applications every time faster and faster into production, but we're not allowed to deploy every time of the day because we can't disrupt users into production. And that's why usually the ops guys tell us that, well, you're only allowed to update your application like midnight, or every weekend, or once a month, or once 2 months, and we need to prevent that, because when we're not releasing too often, we're just increasing the risk of messing something up in production, because our batch size, the amount of changes that we're releasing to production into each one of our versions is too big, right? So I don't have time to discuss today why we should keep the batch size small, but that's one of the main mantras of DevOps. We need to keep our batch size small, and for that, we need something which we call zero downtime, which is your ability simply to release your new version of code into any given moment of the day. And the traditional way of trying to achieve zero downtime in systems used to be what we call blue-green deployments. What is a blue-green deployment? Basically, traditional deployments had just like your environment, which we call the blue environments. You have clients issuing requests directly to your backend deployment, which is the blue one. If we want to create a blue-green deployment environment, we have to add another component to this infrastructure, which we call a proxy. Could be a load balancer, could be a reverse proxy, it doesn't matter. I'm just saying that you're adding a component which is receiving your requests on behalf of somebody and forwarding them. So now that we have a proxy on top of our backend, we can create a replica of our blue deployments and call that a green deployment. Each one of these environments, they are equal, they are supposed to be equal. Each one of them is capable of handling like 100% of the requests in production into any given moment. So some people use that for load balancing too, but the main purpose of a blue-green deployment is for failover, right? If something goes bad, you have another exactly the same environment, you can just route to the other environment, that's how it works, right? So how does blue-green deployments allows you to achieve zero downtime? You have the proxy, you want to release a new version, so you have two different sets of environments working in production at the same time. If I want to update the version of my software, I just ask my proxy to stop issuing requests to the green deployments. I stop the servers, I copy the new artifacts, I start the servers, maybe I issue some fake requests to warm up the server, because you know if you're using a Java application server, you need some requests to warm them up. When everything is okay, I can then maybe ask the proxy to start issuing production requests to my green environments. But if anything went wrong, I still have my blue environment with my older version, so the risk of something bad happening is much lower, because if anything went wrong, well, proxy, just fall back to the blue deployment. I need to figure out what happened with the green deployment, what is going wrong with that, right? But if everything went well, I just can ask the proxy, well, switch the production request to green. Now I'm doing the exact same process again on the blue deployment. I'm stopping the servers, I'm copying the new artifacts, I'm starting the servers, warming them up with some fake requests, and if everything went well, now maybe I can ask the proxy to load balance the requests between blue and green deployments. That's the way that you can achieve zero downtime deployments into production. For the basic requirement for zero downtime deployments is blue-green deployments, right? There are some other things that you need to take care about, like you need to externalize states and everything else, but the basic infrastructure configuration for achieving that is blue-green deployments. If any of you has ever tried to create this by hand, you know it's a lot of work. And luckily for us, Kubernetes and OpenShift, they all provide this kind of zero downtime configurations out of box. You have blue-green deployments, you have zero downtime deployments out of box, and not just this simple scenario. You have much more sophisticated scenarios if you choose to use Kubernetes and OpenShift for that. Some of these more advanced scenarios that we can have, I'll walk through some of them. First, you can have canary deployments. How many of you have ever heard about canary deployments? Okay, one. Well, the other guys, they're not hearing me or something, yeah. Okay, but canary deployments, we take the analogy from the coal mine workers in the past. If you ever heard about it, I'm going to repeat, sorry. If ever, canary deployments used to be the thing that with the coal miners, when you're working in coal mines, sometimes you can hit like a natural gas point in the mine, and to release the gas doesn't have smell, but of course it's toxic and you'll die. And the nice thing is that the coal miners were able to like carry canaries, which serve as two purposes. There are three even. They're beautiful, they sing, and they die very fast, right? So if you ever hit a natural gas and you have the canary singing, for some strange reason the canary stops to sing, you better just run away because you might be the next one to stop singing, okay? So we use the same analogy with deployments. What is a canary deployment? You just try. You just don't want to release a new version of your application to production, and then suddenly 100% of your requests are going to that new version, and everybody is screwed in production. No, you should be just deploying, well, let's deploy a new instance of my server, then, well, let's try with like 10% of my users are going to this new version. Is everything going okay? Okay. Then let's increase the percentage. Let's put like 20% of the requests. It's going okay. But if I increase the request to 30%, and then suddenly my new version starts to behave slowly, then we know my canary died, something is wrong, I need to roll back to the previous version, right? This is a strategy for canary deployments. It used to be very hard to implement this using just the plain old infrastructure tools, but with Kubernetes and especially OpenShift, you have this out of box. So that's let's see, the yellow deployment is the canary one. It starts small, then you start to grow the amount of requests that you are issuing to production. Then, if anything fails, fall back to blue. Everything should be working fine. You can take some time to debug what happened with the canary that went wrong, and everything's okay because users are not being disrupted into production, okay? And the last strategy that I want to show you is rolling upgrades, which is a very sophisticated form of blue-green deployments tied to canary deployments. What is a rolling upgrade? Rolling upgrade which means that we're not assuming anymore that we only have a blue and a green deployment. We are assuming that our application can be running, since we're using containers, can be running within multiple instances distributed in a cluster, which I can have like 10 nodes in a cluster, and I can have like 20 instances, and they might be running anywhere inside the cluster. So I assume I always have more than one instance running into production. If I want to release a new version of my application with a rolling upgrade, I just decide, well, I need at least 2 instances of my application running into any given moment. Well, Kubernetes might decide, oh, we ask for at least 2. Let's put like 1 more instance running just as a fallback, and I'll just upgrade that instance first, right? Because you asked, I want at least 2 instances of my application running into production. Kubernetes just decides to create a new instance. It upgrades, I'll roll back the animation here. It just decides to upgrade first this instance. Well, now I have 2 instances of the previous version and a new one. Then decide to upgrade the next one. Then, if these instances are doing okay, then I can upgrade the last one. Okay, that is the basics of a rolling upgrade. You can imagine how hard would it be to implement this by hand. But Kubernetes and OpenShift, they have this all out of box. Okay, now, crossing the fingers, I just hope that my virtual machine is running for me to show that live. And it's not. Okay, but you know the nice thing about, you can believe that what I'm saying is true because it's a failing live demo, okay? I was supposed to be showing you this running on top of my VM, but apparently I'm not being able to connect to somewhere, some registry due to the internet, but it's happening the whole week here too, okay? What can I decide to show? Well, I'm not going to pretend to you that everything is running okay in the machine because it's not, but since we're here to try to some OpenShift I/O, and I know that many of you are trying the workshop or waiting for the workshop to start, I would like to say that all of this that I said, it's out of box on top of OpenShift and OpenShift.io. And if you want the full feature version of this session that I'm presenting to you right now, it's available in multiple different instances on YouTube. It has been recorded multiple different times. If you type my name, the session that I want to check, oh my God. It's this one. From the Vox France, I'm showing you all of this that I wanted to talk to you today, but it didn't work right now. It's available on the YouTube channel from the Vox France, and I hope you'll be able to watch that. I even tried to practice some French in the beginning, my very bad French, and I don't think it worked well, but I hope you'll be able to enjoy the session, okay? Sorry for the internet connectivity. It didn't work as I expected, but again, thank you very much for being here.